Hello there, children. Today, we're going to look at the rest of the Chapter 3 review. Now, this is problem number 8 from the review. Now, let's go over a couple things. Look at the question in green here, that particular equation. Now, you could graph that as presently constituted, but some of you don't like that. So let's go ahead and turn this into y equals mx plus b form. So what I do is I subtract 2x, in case you're wondering what the heck's happening here. I subtract 2x over, and then I divide every term by -1, or multiply by -1, your choice. Now when I do that, all the signs flip around, but so does the inequality. It's a solid line because it's a less than or equal to. So I graph my line, I go -1 for my slope, and I go up 2 over 1. So -1 is my y-intercept. My slope is 2, so I go up 2 over 1, up 2 over 1, or down 2 to the left 1. I shade below the line because I want my y's less than. So I would shade all down here. Now the line in purple, again, I'm going to subtract x from both sides, and then divide all terms by -2, flipping the inequality around because I divided or multiplied by a negative. This becomes a 1/2, and this becomes a +2. So I go, 2 is my y-intercept, and I go up 1 to the right 2 units is my slope. Now, why is my line dotted, you might ask? My line is dotted because it's a greater than, not a greater than or equal to. So then I want the line above. So now I need to find my quote-unquote double-shaded region, as up here, because I want it above the purple line, but below the green line. What that means is, any point that is in this particular region will work for a solution, which there are an infinite number of those. All right, let's move on to the next problem. All right, so next on the docket here is problem number 9. Now, problem number 9 poses some interesting issues. Namely speaking, if I look at the equation in blue there, I again subtract 5x from both sides, and I divide by a -3. When I do that, again, flip all the signs around, so 5/3 x and a +3, but I flip my inequality around as well, making it less than or equal to. So what I end up doing is I go to +3 as my slope. I would like to go up 5 and to the right 3 units, but that's off my graph. So I'm going to instead go down 5, 1, 2, 3, 4, 5, and over to the left 3 units, 1, 2, 3, plot my point. And then that's how I'm going to graph my line. Now it's a solid line because it's less than or equal to, and I shade below that line down here, this way, because it's less than. Now the reason I'm not going crazy with the shading to start is, I know for myself personally, I'm a little bit messy, guys, as you could probably tell. So I want to make sure I only shade the double shaded region. Now the line in green here, I subtract x, divide by -3. When I divide by negative, flip the inequality around to less than. It was a greater than or equal to. Now it's a less than or equal to. So I go to -1, and I go up 1 to the right 3 units, or down 1 to the left 3 units. It's less than, so it's below. So I want below the blue line, below the green line, which is going to require me to have, wait for it, wait for it, wait for it. It's going to require me to have the shading down here. It means any point down here is in my feasible region. All right, moving on. Now for this next problem, here is my graph. So you see, now why did I not graph this constraint? Well, I know that x being greater than 0 is anything over on this side of my graph, x is being greater than 0. So I look at the line in orange here. All right, I go to -1, slopes 1, up 1, over 1. I want greater than, so I would shade above this line. But I'm looking for, remember, my feasible region. Look at the line in green here, I go up to 7, and then I go down 1, left 1, down 1, right 1, repeatedly. Now, I want to find this shape. If I want below the green line, above the orange line, and to the right here, this is my shape. Now I need to find out what the heck those coordinates are. This coordinate's my y-intercept of my old function, which is 0, -1. This point is the y-intercept of my green line, which is 0, 7. And this is where they intersect, and if you graph well enough, you'll be able to see this. That's the point 4, 3. Now, what the heck does this mean? And by the way, you can't just assume that I also have the point or the constraint y is greater than 0. Don't assume that. We only have the constraint x being greater than 0, which is why I have that triangle there. Now what I do is, the one function I haven't touched yet is my objective function. What you are going to end up doing is taking these and putting them into your objective function. How? So I take these 3 coordinates, and I put them into that objective function and find the minimum and maximum, which are as follows. My minimum is negative 21, found at the point 0.07. My maximum is 7, found at the point 4.3. You need all this information. I need to know what the max is, where it's found, and what the minimum is, and where it's found. So now, let's move on to probably, quote-unquote, 2 of the harder problems on this. So this next problem here, solve the system by elimination. Now first, I'm going to number these systems. That's what I should be doing here. And what variable do I want to go after? Well, as you can see, the A is probably not a good idea, because clearly there's some multiplication by both. B's are a quality choice, because I can just add the first 2 equations together, but I'm going after C's, because, well, I feel like it. So here's what I did. I take -1 times equation 1 and add it to equation 2. The reason I do that is I want to eliminate the C value, and I see they both have a 6 in them. So I go ahead and do that and add up. The biggest thing you want to remember is you do not want to, under any circumstance, miss a negative sign. So you might have to walk out to yourself, be like, all right, equation 1 times -1, it's -5. 3 times -1, -3. -6 times -1 is 6. -7 times -1, 7. And then add them up. Then I need to pick another combination of these and go through it. All right, so I'm going to go with a -6 times equation 3 and add it to equation 2. I could add it to equation 1 as well, it doesn't really matter. So -6 times equation 3, you go, all right, -6 times 3, 18, -6 times 2, -12, -6 times -1, 6, 11 times -6, -66. Then add it to equation 2 and get your stuff here. So now I look here, and what variable do you think I would want to go after? The A's! Very good, imaginary voice in my head. So that's what I'm going to do here. Now, here's how I look at this. I can actually use substitution here, which I did just to show you another example of it. I take and solve the one equation for A and jam that into the other equation that I didn't use. Getting B equaling 3, and putting that back into this first equation to find A. Let's say you didn't have any idea what I was talking about right there. Then if I want to make the A's the same, I multiply the top equation by -22, or -22, or 22. So multiply it by which one? Oh, man. Well, it's a negative A already, and I want it to be 22. Just multiply it by 22. Don't overcomplicate things here. So what I'm doing, folks, is, let's say you didn't see any of this here. This is what I would do normally. I would multiply all this stuff out. And add it to the top equation there. This is if you didn't want to use the substitution method, which, to be honest, may not be your particular cup of tea, if you drink tea, or it may not be whatever floats your mathematical boat, which is fine, but you need to be adept at using it, if you have to. So B becomes 3, and you put it into that top equation anyways. And with these two things, you can go ahead and go find, too far. You can go ahead and find your C value. You can write it as a coordinate pair, or you can write it like this, circling each variable. Now, what is nice about these, remember, you are able, if needed, to find out exactly the correct answer, because you can take -2 for A, 3 for B, and 1 for C, and substitute them into the problems and find your correct answers. All right, moving on. All right, so this particular problem, I am going after the Z's. What? I'm going after the Z's. Okay. So I go after the Z's here because If I look, I see a negative z, a positive z. That's awesome. I can just add those two equations together like as such. And I have a negative 5z. Makes it easy. The x's aren't bad here. I have a single x, a negative 3x, and a 2x. That would be pretty easy to combine together. The y's definitely aren't the smartest idea at all. I have a negative 3, a negative 6, and a negative 4. I would need to introduce more negatives and definitely do some more linear combinations. I want to try to avoid that. So what I'm going to do is multiply 5 times the second equation here and add it to the third equation to get rid of my z's again. Now, again, walk yourself through this slowly. 5 times negative 3, negative 15. 5 times negative 4, negative 20. 5 times 1, 5. 5 times negative 20, negative 100. And then add the third equation. 2x, negative 6y, negative 5z, negative 4. Now, I have these two equations. What variable should I go after, do you think? X is probably your easiest bet here, which is what I'm going to show you right here. X is your easiest bet simply due to the fact that I can multiply the top equation by 2, the bottom equation by negative 13. Truth be told, you can multiply the top equation by that negative 2 and the bottom equation by 13 and be fine. So when you do this, you add them together, you get 39y equals 78. Divide by 39, you get y equaling 2. Substitute that y into either equation. What are these originals? I did the top one, but you can do the bottom one as well, get the same answer. And get x to be 4. Now when you find y and x, how do I find z? Substitute and solve into any equation. I picked the top equation because it had the smallest numbers of multiplications and less negatives. You could have picked the middle one because it had a z by itself. You could have picked the bottom one because you like big numbers. It doesn't matter. But what you need to realize is when you have x being 4, y being 2, and z being 0, that will work for every single problem. It has to. So now you are ready to take on the wonderful, inglorious test. Go henceforth and study more.